Okay guys, welcome back to the first video on dissimilar fractions. I'm not sure how it's called in every country. I do know another way of calling them is unlike fractions, either dissimilar fractions or unlike fractions. An example of an unlike fraction is this, 2 over 4 and 1 over 5. The reason why they are unlike is because they have different denominators. So when you're trying to add them, we run into problems. And before we talk about how we're going to solve this kind of sum, I'm going to show you what similar fractions look like, or adding similar fractions look like, and then what adding dissimilar fractions look like. And when we come to the dissimilar fractions, tell me what, well obviously you can't tell me because I'm not going to be able to hear, but I'd like you to think about what goes wrong, because something's going to go wrong. So let's take this first example that we have here. Just change pens, sorry. Some people probably think I'm trying to copy red pen, but no, honestly it's the best way to do this. So let's start by doing the sum. 1 over 4 plus 1 over 4. Now remember, 4 in a denominator means that we have 4 sections, and we're choosing either 1 or 2 or 3 or 4 out of those sections, and that's what the top number, the numerator, is. So the denominator represents how many sections you've got, and the numerator represents how many you're going to choose. So we want 1 over 4 plus 1 over 4. So 1 over 4 plus 1 over 4, well, that equals 2 over 4. But if you remember how to do, you remember our section on equivalent fractions, this is also equivalent to 1 over 2. And you can see it's 1 over 2 anyway because it's half of the whole thing. But for now, let's just say 1 over 4 plus 1 over 4 is 2 over 4. Now let's do the next section. The next question. 2 over 4 plus 1 over 4. So 2 over 4, that's 2 out of 4, plus 1 over 4. Well, as you can see, that's clearly very easy. 1, 2, 3 out of 4, so that equals 3 over 4. And that's how similar fractions work. Because each and every one of these is exactly the same size, when you're adding one fraction to another and they have the same denominators, all you're doing is picking the amount that's here and then the amount that's there and adding them together, and it's quite clear, it's easy to do. So now let's try this other question, which involves dissimilar fractions, unlike fractions, denominators that are not the same. So 2/4 plus 1/5, well, we've got 4, so pick 2 of them. Then 1/5. Now we're running into a bit of a problem. Can you see what the problem is? Well, this here, that isn't 1/5 in size, it's 1/4 in size, because it's 1, 2, 3, 4, 1/4 of the whole thing. So it's not the whole of that. This, which is the same size, if you see these boxes are the same size, this is what 1/5 is. So really 2/4 plus 1/5, really I should use a ruler, here we go. See if I can get the exact size. It's around 50, 1.5 inches. So that's about there. So 2/4, which is that, plus 1/5, which is this. Now can you tell me what that fraction is? Well, you can't. I mean, this one was easier. You had 2/4 plus 1/4. That's obviously 3/4. But this is 2/5 plus something that's not 1/4. It's not half of 1/4, so it wouldn't matter anyway because you still can't write it properly. It's more than half. It's somewhere between 2/4 and 3/4. So when you've got fractions with different denominators, it becomes impossible to count them in this simple way as when you have denominators that are the same. I repeat, 2/4 plus 1/4 is obviously 3/4, but 2/4 plus 1/5, well, I would have no idea how to label that. So this is why dissimilar fractions are harder than similar fractions, because there's no easy way of actually working out what the answer is. You can't do it visually. We have to find another way.
So long, farewell, I'll be there saying good night. I hate to go.
So, how are we going to deal with this problem then? Well, it should be very clear to you now that the only way you can add fractions is if both denominators are actually the same. Now, sorry, I've got to close this window because all these cars going past on a Sunday afternoon, it's going to make it impossible for you to hear what I'm saying. Much better. Right, so we have this problem. 2/4 plus 1/5, and we can't add them directly because they have different denominators. So what can we do? It looks like we're going to have to create some kind of sum where the denominators are the same. Now, how are we going to do that? By now you should be familiar with equivalent fractions. Just a reminder, when you have equivalent fractions, you can have fractions looking totally different but being exactly the same. Oh, nearly made a mistake. So for example, 1/2 is the same as 2/4, is the same as 3/6, is the same as 30/60. So if we're going to get a sum that has the same denominators, what we can do, what we're trying to do, is we're trying to find an equivalent fraction of 2/4 and an equivalent fraction of 1/5 that will have the same denominator. If we can find an equivalent fraction of 2/4 and an equivalent fraction of 1/5 that has exactly the same denominator, we can just replace these with their equivalent fractions and we should be able to add them up. Now that might sound a little bit confusing at the moment, but I'm going to kind of give you an example of how we would do this. Now, remember 2/5, 2/4 is exactly the same as 1/2, right? So let's do something. Let's start with 1/2. 1/2, right? And down here let's put 1 over 5th. Remembering 1 over 2 is exactly the same as 2 over 4. Oh, sorry, making a mistake here. It's 1 over 5th. Let's multiply them both by 2. Right, times 2. What does that equal? That equals 2 over 4. Now if you times this by 2, it gives us 2 over 10. Alright, let's try and multiply them by something else. Times 3. Remember, when you're doing equivalent fractions, you have to multiply top and bottom by whichever number you're choosing. 1 times 3 is 3, 2 times 3 is 6. Okay, that's interesting. Now let's multiply 1 over 5 by 3 in the denominator and the numerator. That gives us 1 times 3 is 3. 3 times 5, 5 times 3 is 15. Keep going. Stay with me here, you'll see what happens eventually. Now, let's times this by 4. One times 4 is 4. I'm going to put them over here. 2 times 4 is 8. Now let's multiply the denominator and numerator of 1/5 by 4. 1 times 4 is 4. 5 times 4 is 20. Now I'm going to do something which may seem unusual at the moment, but keep following me and you'll understand why I did this. What will happen if we multiplied 1 over 2 by 10? And numerator and denominator. Well, 1 times 10 is 10, and 2 times 10 is 20. Now if you look carefully, you can see that all of these fractions are equivalent fractions to 1 over 2, and all of these fractions are equivalent fractions to 1 over 5. But if you look carefully, in the fractions that are equivalent to 1 over 2, we've got 10 over 20, and in the fractions that are equivalent to 1 over 5, we have 4 over 20. In other words, we have equivalent fractions of 1 over 2 and equivalent fractions of 1 over 5 that have the same denominator. If we want to add these two now, it's simple because we have 20 in the denominator. But you might be asking, wait a minute. Why are you using 1 over 2 instead of 2 over 4? It doesn't matter. 1 over 2, 2 over 4, 4 over 8, 3 over 6, 10 over 20 all equal exactly the same thing. I was just using 1 over 2 because it was the easiest number to multiply. So in other words, 10 over 20 is the same as 3 over 6 is the same as 4 over 8 is the same as 1 over 2. 2 over 4 is the same as all of these. 4 over 8 is the same as all of these. All of these are the same as each other. So what we can do is replace 2 over 4 with any one of these numbers. And what I'm saying is we're going to replace 2 over 4 with 10 over 20 because it equals 10 over 20. And then we're going to replace 1 over 5 with 4 over 20. Now, what does that mean? That means that the sum 2 over 4 plus 1 over 5 is exactly the same as 10 over 20 plus 4 over 20. Can we do that sum? Of course we can. Why can we do it? Because they share the same denominator. What's 10 over 20 plus 4 over 20? It is 14 over 20. And there is our answer. So from the beginning we had two fractions that don't share the same denominator. But then what we did is we went through several numbers that are equal fractions with this, and several numbers that are equal fractions with that. We found a pair that match denominators. Once we found that pair, we can then add the pair together. And adding these two pairs together is exactly the same as adding those two pairs together. Now maybe you're a little bit confused at exactly what is going on here. So I'm going to break this down even further. We learned that 2 over 4 is exactly the same as 10 over 20 because it's an equivalent fraction. We also learned that 1 over 5 is exactly the same as 4 over 20 because it's an equivalent fraction. How did we get these equivalent fractions? We did this. We didn't actually do this, but this is what is happening. 5 times 4 equals 20. And obviously, to create an equivalent fraction, you have to multiply the top by 4. 1 times 4 equals 4. And 4 times 5 equals 20. And obviously, if you want an equivalent fraction, you have to multiply the top by 5. 2 times 5 equals 10. And the important thing in this is that we need, in order for us to add fractions, the point to always remember is in the end we need the denominators to be the same. So we multiplied this denominator by 4 and it gave us 20. We multiplied this denominator by 5 and it gave us 20. What does that mean? Well, it means that 20 is a multiple of 4 because it's 4 times 5, and 20 is a multiple of 4 and 20 is a multiple of 5. Now what does that remind you of? When one number, in this case 20, is a multiple of two different numbers. Do you remember what that means? Where one number is a multiple of two different numbers. In other words, 20 is a multiple of 4 and 20 is a multiple of 5. If you can remember from our video on common multiples, this is exactly what 20 is. It is a common multiple of 4 and 5, because 4 times something is 20 and 5 times something is 20. And just in case you don't believe me, let's do a table and write out the multiples of 4 and 5. So 4, 8, 12, 16, 20, 24 and so on. 5, 10, 15, 20, 25 and so on. Now we can see clearly that 20 is a multiple of both 4 and 5, and it's quite clear that it is the lowest common multiple of 4 and 5 because there are no other matching numbers in this table that are below the number 20. So what does all of this mean when we put it together? Well, it means that if you have two fractions that you're trying to add, but they have different denominators, in order to do the sum, you need to find equivalent fractions of each of these fractions. So you need to find an equivalent fraction of this and an equivalent fraction of this that has the same denominator. We found those equivalent fractions. The equivalent fraction for 2/4 was 10/20. An equivalent fraction for 1/5 was 4/20. And actually how you do that is by writing out a list of all the multiples of 4 and all the multiples of 5 and finding the lowest common multiple. Once you've found that lowest common multiple, you have to ask yourself, how many times do I have to multiply the denominator in the first fraction to get the lowest common multiple? How many times do I have to multiply the denominator in the second fraction to get the common multiple? Then multiply, when you found that number, multiply the numerator and the denominator by that number, and it will give you the equivalent fraction. So for instance, I found out that our lowest common multiple was 20. I have to ask myself, how many times do I have to multiply 4 to get 20? 5 times. So then I take that number 5, multiply 4 by 5, and I do it for the numerator as well, because that gives us the equivalent fraction. Alternatively, or not alternatively, but exactly the same with 1/5. We have to ask ourselves, how many times 5 needs to be multiplied to turn into the common denominator? 5 times 4 makes 20. Take the number 4, multiply numerator and denominator, and we get our equivalent fraction. Then once we get the equivalent fractions, all you need to do is understand that the first fraction plus the second fraction is exactly the same as the first equivalent fraction plus the second equivalent fraction. And there you'll have your answer. What we'll do in the next video is we're going to give several examples so that it becomes clear how this is, because it seems quite complicated. There's many different steps, but what we'll do is we'll go through the steps more carefully, give you maybe about 4 examples. By the end of that video you should be in a position to work with any or many of the questions where you have to subtract or add fractions with different denominators, that is, unlike fractions or dissimilar fractions. So until the next video, which I'll upload shortly, we'll